All right, we're going to talk a little bit more about teaching with R. And there are some documents. I'm not quite sure how to control the size of this font, but this is a sort of syllabus for the day. I'm going to have you do some stuff, and so you need some links, which are on this. So if you go to rpubs.com, DT Kaplan, and then notes, just like that. I'll give you a second to do that, and you should get this page. Yeah, it is small, isn't it? OK. And then if you want this slides, such as they are right now, just change that last little bit to NIMBioS. I think it's all caps. Yeah. They don't work for you? Oh, yes, absolutely. Sorry. No, and I'll send you the HTML. That'll be better.
I know that it doesn't work for me.
Yeah, we've been talking. I don't know what that is. All right, and then I'm going to use, I don't want to have the headers. So here, these are going to be my slides, except that's a mistake. Jump, jump, jump. Let's see if this one's going to work. Hide toolbars. Well, let's see what happens. I might have made a mistake just in correcting things. Put it into presentation mode. OK, here we are. Yesterday, we talked a little bit about Markdown. And I'm hoping you wrote a biography or something like that in Markdown. You didn't yet use R in the Markdown document. We're going to do that again today. And you know enough about Markdown from yesterday. And also, we talked about this Mosaic package. And you've probably already installed it from yesterday. But if you would library that in. I want to say load, but library that in. And then it will also be convenient if you library in NIMBioS, which you probably had installed or installed from yesterday. You don't need that so much. All right, when I yes? Oh, sorry. If you're in our studio, you can just install it through the Install tab. Okay. It's a CRAN package. OK, when I don't have it. Gosh. When I teach a course, I typically have my syllabus done, believe it or not, in Markdown. And so this is the syllabus from a course I taught in the fall. And I have a calendar and then the various administrative stuff that nobody really cares about and some links. And then I put the day-to-day syllabus, let's see if I can make that bigger, day-to-day syllabus also in Markdown. And I assemble this as the semester goes along. And then I typically, I don't know what will happen now, I typically have the notes that I use from class, which I put up. And the students like being able to see those notes straight off. So then they don't necessarily have to take notes. I realize some people think you should. So that's what I've got for you today from that first RPubs. Is these links for teaching R. So we're going to refer to this, but I'm going to refer to the slides. So here we are. OK, so yesterday I mentioned some principles. The ones in italics are the ones that we've done already, so I'm not going to come back to those. And these aren't in the order we're going to do them, but illustrate a professional workflow, give students a working scaffold. You can see those are the principles I'm going to try to illustrate with R. I've talked to people, and they suggested some additional principles, maybe not in that way. One is, have your students do things by hand. right? The course, typically a course is not about the computer. It's about some area of biology or statistics or mathematics or whatever it's going to be. You want to make it about that centrally. And don't make the course about teaching the tool. And quite a few people told me that they've interacted with people using SPSS who only know how to do it in SPSS and not even what it is, just how to do it. Okay. So I'm going to have you do something by hand, not this. I have a critique of doing things by hand, but often, in teaching statistics at least, the point of doing it by hand is to make sense of a formula that's otherwise impenetrable to the student, depending on his or her background in mathematics. So the mean isn't too bad. Oh, look, there's a mistake in the mean. Isn't that good? I'll just show you how one addresses that so that you'll think I made that mistake on purpose. And so, sorry, that's really small. So all I have to do is edit this file. And I could even do it during the class, let's see, like I'm doing now. And I don't want to be embarrassed about making mistakes. There it is. I don't want to be embarrassed about making mistakes. You make mistakes. And the point is to deal with them, is to correct them, is to identify them and correct them. So that's what I'm going to try to do now. And I'll bring up my fixed pages. There are better ways to do this. But that's why people do things in hand. And the thing is, by hand is actually a technology. It's just such a traditional technology that we don't think of it as a technology. But we rely on things that are relatively new. Pencils, right? Only about 500 years since pencils were really the cutting edge thing, the XP or whatever it would be. Formulas and tables. I think a lot of the time when you're doing things by hand, you really ought to do them by eye. Right? That what you want to do is not a calculation, not arithmetic. The computer does arithmetic. And what you want to do is not necessarily to have people look at a formula long enough that they somehow figure it out or translate it into an arithmetic algorithm, but you want them to form an intuition. And here's a by hand task or by eye task. What's the standard deviation of that distribution? 25, good enough, right? Basically the half height, the half width at half height. There's some ambiguity there. That's, I think, the important skill. Or if I gave you points on a line, here's minus 200 to 1,000, just to make it confusing. Standard deviation of that. 300, good. Good enough. You want to know exactly what it is? Do the calculation. But I want you to be able to eyeball certain things. And I'm going to show you one other example, which you will groan about, but that's fine. Let's see if I can find all these things. Trump. I'm not very good at screen management because I can't see my screen. What do I do? It's going to zoom out, isn't it, itself? At some point? Oh. You're seeing the slideshow. OK, forget that. I'm going to do it another way. Sorry. No, I can't get to it. Oh, that's really embarrassing. OK, that's really embarrassing. Oh, escape. Escape is how we do it. Gosh. You're going to groan, but I'm going to do it for you. Is that it? Where did it go? Oh, now this is embarrassing. There we go. That'll have to do it. Slideshow? No, that's what I did.
Enter full screen.
Enter full screen. OK, that's the full screen. All right, oh, I should take this slide off. What I want you to do by hand is do one sample t-test, as they call it, right, on this set of data. 2 numbers. OK? How do you feel about doing that without looking at the instructions?
Not great.
It's 2 numbers. Anyone say, well, that's easy? I know about the t-test. I can certainly do that by hand. Also, this is a non-professional workflow, so you shouldn't do this anyways. But so what you would do is you'd calculate the mean. You can do that by hand. What's the mean? 4 and 10? You can read it. That's also. You're going to have to say the number before I go on. There we are. Thank you. And here's the standard deviation, and I'll leave you. I won't make you say that. And then what do? You take the mean, you divide it by the standard deviation, and then there's a root n in there, right? That gives you a t statistic, and it's going to be 7/3. And then what? Two data points, t is 7/3. Finish up the calculation for me. I mean, I gave it to you here. How would you do it? Degrees of freedom is 1. You'd look it up. And I could say, where does the t distribution come from? And usually someone will say, what? From the, OK, that's the one I heard. Where does it come from? The back of the book. OK, at that point, you're not doing it by hand. So I want to show you another way to do the t-test. Not that you care about t-test, but just to show you what you can do by eye. All right? You can, of course, do it by saying in SPSS or anything you want, saying, oh, here's the command. Go and do it. Fine. And then you're reading stuff and you're interpreting it. That's fine. But we're going to do the t-test with a protractor. All right? And what I would have you do, if I weren't pressed for time, is have you draw out roughly a coordinate grid, and then plot the point 4, 10. 1, 2, 3, 4, and then up to 10. All right? Does that tell you what the p-value is? OK. The null hypothesis is that those 2 numbers have the same, come from populations with the same mean. And if that were true, they would be coming from somewhere on there, on that gray line, that diagonal line. All right? And the further that they are from the diagonal line, the more evidence you have that they're not coming from the diagonal line. We need a statistic to use. And you're sold on the t-statistic. But actually, this angle is a perfectly good statistic. And that's how the t distribution is derived in terms of that angle. And everybody knows what an angle is. And you can see it by eye. And I put it on the slide, stupid me. But just look at it and guesstimate the angle. 20 degrees. Good. All right. Now, what we're going to ask in the hypothesis test is 20 degrees closer to the diagonal line than we'd expect just by luck if the data were just being generated randomly? All right? So if they were being generated randomly, they could be at any angle, equally likely, right? So to be closer, the random point would have to be in there. Or it might have to be in there. Or it could have been close that way or that way. So take the angle, 20 degrees, multiply it by 4. What do I got? Thank you. And divide that by 360. OK? And that's the p-value. 1/4. That's where the...
What null and alternative hypothesis are you testing?
What a... Yeah, I hate hypothesis testing. So the null hypothesis, it's a one sample t-test that the 2 numbers come from the same distribution.
So one sample t-test, the assumption is that you have a sample from the null distribution. The t-test statistic you gave was that they have a mean of 0. You know that the mean is 0. The assumption is that your sample, if they all fit their IID.
ID, but the mean doesn't have to be 0. The mean is just the same.
The test statistic you gave was for the null hypothesis, the mean is 0.
No, because the numbers could have come from anywhere. Oh, you're saying because they might be over here?
The statistic you gave, that was a one sample test statistic.
Oh, that's a good point. That's a good point. So I would just,
We're not testing that they have equal mean.
I just have to subtract out the mean, but you're quite right. You're quite right. All right. So I haven't done a compelling job, because I screwed up, of showing you that this is the t-test. But that's, we can talk about that, and it sounds like you're right, and it's just another assumption implicit here that I haven't.
So what you're testing is that they come, so you're doing a two-sample t-test with one observation from each sample. You're testing that observation.
Yeah, you know, I said one sample t-test, and I should have said,
Two-sample t-test, but you have your n for each group is 1.
that, or I should have said I'm doing the t-test on the difference between them.
But you have 0 replication.
Yes, I have 1 degree of freedom.
Your degrees of freedom is
I'm not,
0.
yes, we'll have to talk about it. It's another matter, but that's a good point. But the t-test actually comes from the same logic in higher dimensions, if you've got it. And so if you can find, this is my youngest, if you can find a point on the globe that represents your 3 numbers, let's say, what you're asking is what's the probability of it being closer to the North Pole than that? And that's something you can eyeball. Right? Being able to eyeball stuff is better than being able to calculate it once and then forget how to do it. And you can see that these are Beamer slides. So they're from some time ago, which I'll use as an excuse for why I screwed up the way that you're describing. All right, so I'd suggest doing things by eye. And I want to say, going back to these principles, don't teach everything at once. And we sometimes do that when we give students data. We give them data that's in the form that we found it. And there is something valuable there. Professionals need to be able to turn data from the form that they found it into a useful form. This morning in the ggplot talk, we saw some examples of that where stuff was being converted to a factor and the like. Don't do that. Give them data that's in a nice format for operating on, and then make it another lesson how to get it into that format. Right? But make it easy for students to do the calculations that you want them to do. And later on, you can say, remember that simple data set? This is where it came from. It took some work to get there. And I'll show you a quick example in a little bit. OK? And I'm not going to show you that example, because I know where that's going to go. All right. So here is a lesson that I'm going to have you do. So I said, make technology central to how and what you teach. So I want to teach you, I really hope I want to teach you. You'll see how much I screw up. But I want to teach you about the F statistic. All right? I want to teach you about that and where it comes from. Why should you care? But so back on your template, where do I go? I go up here. Back on your schedule, this thing, you have this link to a scaffold for the in-class activity. Click on that. And what you should see is sort of typewriter font stuff. Is that what happens? What's junk worth? Exactly. That's what this is about. But I want to make sure. Are people able to get up that page of type of courier code? No?
If you right-click it, yeah, right-click it.
Actually, that makes it interesting. I was the one having issues on it as well. Don't just click it, open it in a new tab.
OK, there we go. Now are you able to get it? All right, what I want you to do is copy that whole thing and paste it into a new editor window in RStudio. So I'll do that now. Oh, right, because it's on RPubs, right. Open link in a new tab. Then get to the new tab. Where did it go? Oh, here. So it should look like that. Right. So I want you to cut all of that out. Here you go, the whole thing. I can't do it, but you can probably do it on your screen. Then go to R, or RStudio, I should say, and open up a new file. You can make it an R markdown file. So open up that file And then mine, I have a different version than you do. And then paste in the stuff that you have on top of what's there now. Oh, you see, well, paste it in there. Sorry, I've got other things there. And then delete all of this, the stuff that was originally there, which we don't need. Is that working? That's a lot of steps, but people able to do that to get? That sounds like a no. That sounds like a no. All right, so what I wanted to do was copy this out, except it won't let me do that in full screen mode. So I'm going to go to stop. So I'm going to copy this out, just like that. Then go to RStudio and paste it in an empty document. Does that work? That's a yes? Good. All right. So it works for some people and not maybe for others. But I'm going to move on without getting it to work for everyone. So here's this document. This is what I'll call a scaffold. And there are nicer ways to distribute scaffold so that you don't have to do this cut and paste. So you can just give the name of the scaffold. But I haven't set that up for you. And the scaffold is in the form of an RMD document that I wrote. And it's more technical than the RMD document that you wrote yesterday. It has some metadata. Right? It has some boilerplate in it, stuff I don't want you to change. But I made this thing because I have a certain limited amount of expertise. And I want to pass that expertise along to you so you can use it without your having to reproduce it. Because it's not about teaching you how to produce documents for teaching. But when I'm teaching the students, it's not about that. But here you have a template, and compile it to HTML. And you should get something like that. No, come on. Is that compiling for you? Yes?
It's easy to choose encoding.
Oh, just choose any encoding. It's the title's not showing up. It's because you have an old version of RStudio, and it doesn't know how to read the metadata. Oh, that didn't occur to me that on the server you'd have an old version. If you let's.
I'm actually using the new version. I couldn't get the server to open, so I went to the new version that I downloaded yesterday.
Well.
Did you get it on GitHub? The latest?
Yeah. Did you? So did you get? There's the version that they have on the front page is not the newest version.
Oh, okay.
They have a daily build. All right. I just forgot about that. I'm going to show you how to fix it. You don't need the metadata. Delete this. And just say, what's junk worth, or whatever you like. And put an equal sign under it. Sorry, I forgot that. And that should work for you all. Better? I'll show you what.
Is there a way to comment? I thought the number signs were the comments.
In R, number signs are comments, but this is markdown. All right, and in markdown, this is another little technical thing. You have to use an HTML comment symbol, which is not always what you want to be doing, right? I just want to know if people can compile this way.
Do you have to save it as a file to compile it?
It depends on the version of R you've got, so you may have to save it. The version of RStudio you've got. Okay, we're there, at least for some people. All right, this is sort of the gratification that I want students to. They're going to start with something that works. At least I hope it works. And this is a little lesson about R squared. And it's a lesson about nested models, and you can just read it if you want, but I'm going to talk at you. You know, as you add terms to a model, R squared tends to increase. Right? This is a lesson for an introductory statistics class. And here I've got some nested models, right? Mod 2 is nested in mod 3, and mod 1 is nested in mod 2. So I expect that the R squared from that is going to be the smallest. That one's going to be the biggest. And that one's going to be in the middle. OK, I'd like you, please, to calculate that and put it in your report. To do that, what you'll do is go back to the template, if you can get a mouse there. Go back to the template. It says task 1. You're going to enter the R code to get the R squared. It's not a formidable task. But I do have to show you some new syntax because you're seeing it for the first time. In this RMD file, you start a line with 3 backticks. It has to be backticks. And then you put a little R in curly braces. And then sometime later on, 3 more backticks. And you can't see it on the projector, but you probably can see it on your screen that it's grayed out a little bit in between the backticks. So just do that. That's a fence, or a chunk, it's called, in RStudio. And then I want you to put in that chunk the R code you want. So does anyone recall the R code for finding the R squared of, say, mod 1? Yeah. All right, and then I'm just going to compile it. I'm going to work with this document. All right? Rather than working with the console, rather than cutting and pasting from the console, rather than worrying about the state, I'm just going to work from this document. If there were an error message, I would see it. And so is that claim about nested models in R squared, is that supported by this? Yes, who said that? Yes, thank you. And what do you see to make you say that? It's really just a little bit higher, isn't it? Right? So, you know, all these other terms in mod 3, the interaction terms and stuff like that, they're really not doing very much compared to what's in mod 2. OK, that's something. Please. So 3 backticks delimits the text that's going to be interpreted as R code. And when it interprets it as R code, then it will print out by default, it'll print out the input command and the output. All right? And this was cleverly done by the fellow who built NIDAR so that he could just copy out whole blocks and see if they worked, because the answers are commented out. But that's not so important. Task 2 I'm not going to do, because I'm already behind schedule. But in a typical exercise, I'd say, OK, now you go build something that shows this. So find some other data set and make models that are nested, and then show me that R squared behaves in the anticipated way. And the thing is, I've given them a huge hint here. Right? I don't want them to get hung up on LM at this stage in the course. At some point, they just have to be able to do that without referring to anything. But I've given them a huge hint. They can refer back to that hint. They can copy out the code. The main technical problem is remembering the backticks and typing correctly. All right. So, but I'm going to do something else. I'm going to go to the next stuff, generating junk. All right? And let me do this in R, and then I'm going to have you do it in your page. So here's the console. I'm just going to do it in the console. Come on. All right, I'm going to build a model, and I'm going to add in pure junk terms to it. All right, and I'll use a data set that's a convenient size for example, but you could use any data set. I'll use a data set with about 500 rows from the current population survey. And so what I want to do is calculate the R squared of some model. And in this case, it's going to be wage modeled by age and education, and then some junk. I'll do 100 terms of junk. And the data is CPS 85. So I'm hoping this will come up with an R squared. Oh, isn't that? Yeah. OK, the warning message is from something else. Another problem I'm having. I got 0.33. You try it. Did everyone get 0.33, or someone who's got you got 0.33613? 0.36? 0.35? What are you doing wrong? Exactly. I mean, you all know this, but students don't know that. They think the computer should do the same thing every time. And you can go around the class. And I'd like to go around the class. So what I'd like you to do is pick some number for this in here, for the 100. Some number you like between 10 and 600. All right? You pick the number and get me an R squared. You able to do that? OK, now I want you to report on your number. So in that compiled document where it says generating junk, there's a link right here. All right? And I'm hoping this will work, because nothing else seems to work. There's a link right here. And open that link up. Whoops. Open that link up. And it'll open up in your browser. The permissions aren't set? Isn't that fantastic? OK.
But it works
If you
knit it,
yeah?
and then you click on it, it works. But you can't edit the document.
You can't edit. Oh. All right, so I'm going to show you what I would have liked to have you do. Where's junk? Generating junk. There it is. So what I would have liked to have you do is see that Google spreadsheet. Someone's able to get into it, but you can't write?
Yeah, you can't edit.
OK. Ow. That's so stupid. Public on the web can find and view. Oh, I saw the change there, and I just thought, oh, they can change. Try it now.
I'm using my desktop RStudio, and it works fine.
OK. Is anyone able to enter something here?
Yes,
Do it then. Show the other people so they don't think they have an excuse. So I want you to enter the number that you asked for, 10, 600, 423, and then the R squared that you got from that. Yes. Who's that?
That's me.
OK. Outstanding. And students actually sort this out pretty well. Even if you have 30 students whacking away at a spreadsheet, they stay away from each other. Sometimes people will put down initials that are obscene, or but it's a small enough risk. All right. So we're going to do this. I want to get a few in there. OK, SPA is whom? Sorry? Why do you think you got an R squared of 1?
There's a lot of free parameters to explain.
Right? There's only so much data. All right? So I'm not going to do it now because it takes too long. But in that page, the page on RStudio, you'll see the command. I'll show it to you. Sorry. You'll see the command to read in the data from that Google spreadsheet. And I just give that to the student. So that will do it. All you have to do is execute that. I'll try it now. Your format's not fantastic, but we don't have very much time. So I just ran it. Oh, I have to republish it. Oh. When you're trying to do something in a rush, that's what happens to you. File. Publish to the web. Republish. So I can read it in. We've got a lot of NAs, but those are the data that you entered. And I would have the students plot this. The R squared versus M, the number of degrees of freedom is what we'd call it in shorthand, but they don't have that. I'd have them plot that. What do you think the plot's going to look like? All right, I'll put the axes down so you know kind of what I'm talking about. Here's the number of random vector, or the number of coefficients. The instructions give that. I'll call that M for the model. And here's R squared. And R squared can go from 0 to 1. What do you think this graph is going to look like? Like this? OK, continue up like that. It's got to level off at 1. All right. And when you plot out these data, actually what you'll get is a scatter of points like that. And then the next item in there is to say, you build another model, and perhaps you'll get a dot here. This is the real model. This is based on junk. What test how would you decide whether or not that test, that real data, is consistent with the junk data? It certainly seems to be out there. How would you decide about that? What would you look at? You understand what I'm saying? So you did a real model. I sped through it, and you got an R squared of 0.6 or whatever. And as a class, we've done 500 of these things, and we've got a nice scatter of points, which will look like that. All right, there'll be some out here, right, that are all 1. What test statistics should I use to judge whether I can reject the null hypothesis that the vectors you added in here are no different from junk?
You could not use a test statistic at all, but really just look at the distribution and see whether your observed data falls inside the 2.5 quantile or the 97.5 quantile.
No, I'm looking over your head. Sorry, wasn't. Yes, so look at it. I was trying to figure out who was talking. I didn't say anything.
Sorry. I forgot what thing. You can just make a histogram of all the things and look at the lower 2.5 quantile and the upper 97.5 quantile, and that's a two-tailed test to look whether your observed value is outside the bootstrap. This is basically a bootstrapped distribution or a randomization distribution.
OK, so you could do that. You could just look at it and say, that's an oddball point. It's pretty obvious. Anyone know what the official statistic is? You certainly could say, well, for this number of degrees of freedom, here's the, the normal or so distribution, as you were saying, and what's my z-score on that? You could do that. But anyone know what the official distribution is?
Probably F.
It's the F. What is F? It's the 6th letter of the alphabet. What is F in terms of this graph?
Distance vector?
OK. The F statistic, ratio of variance, it's a good thing to say.
Explained versus unexplained.
That's right. Good. Explained versus unexplained. If you just have junk, R squared will increase this way. If you have something other than junk, presumably it will increase faster. The F statistic is the slope of this line divided by the slope of that line. This line corresponds to your actual model. This line corresponds to the null hypothesis with the number of degrees of freedom left. Right? And F is just this ratio over that ratio. And if you're interested in degrees of freedom, you can see where they come from in a slope. Right? That's what F is. You could do other things. You could just use R squared as you were proposing to do. So one way to use technology is to go back to the, as I did not do very competently, go back to the basic principles of generating data from a null hypothesis, and allow the students to organize that according to the theory. Right? And probably you're thinking, no, that couldn't be what f is, right? That it must be something else. But that's what it is. That's where it comes from. And that works for any data set. And then I'd have you confirm it on your own data set and do the ANOVA test and see what f is and what the p-value is for your own stuff. Yeah?
I was looking at your book. I teach regression sometimes. So, this is a nice plot. I haven't seen that before. But, there's also that other more common picture of the response vector y being projected down into the
Yes, yeah.
the range of the x's. And when you do this, do you get confusion between those different pictures? I mean, if you show them lots, it is very interesting that there are these different graphical representations, but then is there confusion about which was which and what was? I mean, presumably in the same course, you would show them that picture as well. Perhaps.
Yeah. So one of the skills that we assume students have, but which they don't have, is how to read a graph. Students look at the shape of the thing, and they don't look at the axes. Right? So they don't try to imagine what the graph could be. And it's always helpful to give them exercises in figuring out what a graph is about. And I'll show you one. I'm not going to have you do it as a template. That was my original plan, but I misestimated the time. I'm going to show you one which you can do, you can look at now. And even though you guys are experts, we'll see if you can figure this out. There's a data set called birth 78. I'll show you what it looks like. It's how many babies were born on each of those days. All right? And it's a nice exercise in statistical literacy to say, is this babies in Minnesota? Is this babies in the world? Is this babies in the US? And they can try to figure that out. But here, I'm just going to make a plot. XY plot, births against day of year, data equal births 78. What's the story there? Right, so there aren't so many babies born on the weekends. That's a good hypothesis, right? And you know what this axis stands for. This is the year playing out. At first, students won't see it. They'll just see a wave, and they'll say, "Oh," they won't even know what it is. They won't be able to give any coherent explanation of why it looks this way. But in fact, what's happening here is that on the weekends, births are systematically lower than they are on the weekdays. And you have a theory for this, which is?
Well, you don't generally get confused or have a planned cesarean on the weekend because most doctors don't want to work on the weekend.
Okay. And if you wanted to make that theory that it's the weekend and not Tuesdays, nobody likes giving birth on Tuesday, right? How would you change the graphic? Yeah, you'd color in the day of the week. And you'd see these are all 2 particular days of the week, except there are a few other days when people don't like to have babies. Holidays, and you'll see the holidays stand out, right? And then there's a day when people really like to have babies. No.
February 29th, right?
No, I only have 1 year's data here. Okay, I can't give you an opinion about leap day. Come on, a day when people really like to have babies. December 31st.
April 16th.
Because then you can get a tax deduction for the whole year. And it's not as if you're planning in March. Okay, let's go for it. Right? It's that if you're 9 months pregnant and it's December 27th, you say, well, maybe it's time to induce. And you'll actually see that in these data, that it's higher towards the end. Christmas gets in the way. People don't like to have babies over Christmas. Then they recover and they realize money's at stake, and they'll do that. Okay, so I would have students, I would have you, what I was going to have you do, write up a kind of lesson based on this, where you give them the data and you make a graph, and then you say, okay, your job is to make a more informative graph, right? Or to calculate the day of the week from the day number, which isn't hard, but your job is to do that. And you'd give them this scaffold, and they would add in their own stuff until they've got that done. Oh, this is just bugging me. Oh, too many things. Sorry, I just lose track of where windows are, and that's not a good thing. I'm trying to get to my notes for the day. Gosh. View and browser. There we go. All right, so I'm just going to show you a couple of other things because we only have 10 minutes, and I'm falling apart trying to maintain my screen here. Yeah, so never start a class with, you're going to learn R and it's really hard and you won't be able to do it. Tell them that they will be able to do it, and they will be able to do it. All right. And I was saying about a professional workflow. When you're a professional, you have to document things, which might be a lab notebook, or it might mean keeping track of all of the commands that you're doing in a simulation or some calculation. Right? So you should do that for your students. You're teaching a class, you're using some commands, put them into a document so they can get back to them. The students will always ask you for a copy of your commands anyways, so you might as well give them a coherent document. Here's the last one I'm going to do. Don't code in front of students. I know it makes you look smart, right? It's esoteric, and they can't do it, but they don't understand it, and they can't distinguish between what they don't understand that doesn't matter and what they don't understand that does matter. So you should focus on just the things that do matter, with an expectation that they should understand almost everything. Right? And that means don't code. And you may not think of these things as code, loops and conditional and indexing brackets. But to the students, they are. They've never seen indexing brackets of the sort that get used in R or C or any of those languages. They've never seen a loop, and then loops have a lot of overhead in terms of accumulators. So one thing I was going to say is to use these types of functions when you have to repeat something. And you can see that in the vignette for Mosaic. But I want to give you another sort of lesson, and then I'm done. So not everything has to be perfect. Your class notes are not for publication. Right? Use the defaults. The defaults are generally pretty good. The nice thing about R is that axes labels happen automatically. They may not be exactly what you want, but they're informative. They say what you were plotting. And of course, students have to learn always to label axes. So I'm going to have you now do ggplot without the coding. Okay? And I'll be interested to see what doesn't work now when I have you do this. So you have to load in the Mosaic package if you haven't done that. And I'm just getting, this is a bug from something else. And then I'm going to give you a data set. Well, here, we'll do it together. I'll do it first so that you can see how it works. Yesterday, we had a deer data set. That was yours, right? We had a deer data set. And I didn't really like the format of it. And you don't have access to this. I'm going to do it, but then I'll give you data you do have access to. I restructured it like this. I didn't need the dummy variables and such. I want to explore this graphically. So I'm going to say mplot deer. I'm going to hand a data frame to this function mplot. And it makes a plot. Not very interesting. But RStudio has built in a kind of easy-to-do GUI. So here, I can say, oh, I like ggplot. I think it is prettier. And I'm going to make a scatter plot. Why not? I'm going to use the farm on the x-axis. And I don't really understand this, but I'm going to use the amount of bacterial something on the y-axis. And maybe I'll color this by sex. Or maybe I'd rather make sex different facets of it so that they don't overlap one another. And maybe I'd like to have a log scale, which you're not seeing because my screen is too small. But at the bottom of this thing is a little thing that says log scale. Right? That's a way to get started with ggplot. Right, you're assigning variables to the various traits. And then if you want to see what the code is for doing that, there's the code. You could put that in a document if you need to put it in. Right. And there's a similar function for bar plots, letting you do all the different kinds, or most of the different kinds of arrangements that you do. So here, I contradicted myself, because I suggested at the beginning not to do something like rcommander. And this is not nearly as sophisticated as rcommander, but sometimes the code is just too daunting. It's not going to happen without errors. So give people some way to generate the code for a particular narrow task. And these things, these sorts of functions are actually very easy to write in RStudio. Right? If you can do the graphics, you can do the interactivity with the user. So if you have particular tasks, right, that you want to show different species or something like this, you can write that in a very short amount of time in RStudio. And then I won't go into it, but then if you want to have something that anyone can use, even without R, it's more difficult to program, but there's a package called Shiny, which lets you create interactive apps for that just run on the web. And I'll show you where that is in the links you have. The links you have. There we go. I put some Shiny apps here. Here's one I wrote. You can imagine when I wrote it. For the 2012 election, right? And it was about predicting the electoral college vote, right? And without much effort at all, the students can slide things around. And then I wanted them to make a prediction based on likelihood. You may like the Bayes app that a student of mine wrote. He really put a huge amount of work into it. So one of those links is to Bayes. But there are ways to interact with students without relying on someone else's GUI. The GUI can reflect your expertise and what you want the students to see. So I'll stop there. Sorry for the technical glitches. They always seem to happen, but one works through them. That's really what I have to say about teaching with R. Thanks.
Any questions? I have a question. You said don't write code in class, and I guess I have to agree with that because all kinds of problems could happen. But if you give people code, you can tend to go too fast. It's like slides. You just go too fast. Whereas when you used to have to write on the board, it would pace you nicely. Any rules of thumb about how to pace yourself when you're doing
So
this?
you're exactly right. This is the great advantage of writing on the board, is that it keeps you honest. It slows you down.
Okay.
And there is the potential to say, just to give them a swath of code. So how to pace yourself? What I tend to do if I'm doing a calculation in class or I'm leading them in a calculation, stop that, is I will have a document for each class. Right? And today's commands. And then I will write the statements there as I need them. Right? And I could do it in that RMD sort of way, or I could just do it in a regular R file. It doesn't make a huge amount of difference. But then I do have to type the statements. They cannot be elaborate because I'll screw up. Right? So I have to keep them simple, and that's, I think, to the good as well. But yes, to say, point at something and say, here you see this, next slide, or just generally to use slides, it has that problem with pacing that you point out.
I frequently do that. Regret it, like yesterday. Okay. Thanks so much. That was great.
Thank you.
Okay.